Okay, let's have a look some more examples. Okay, about mensuration. Now, question 8. This question similar to CE question 2008, question 13. Okay, this one like now DSE question session A2 question. Okay, let's see. Now here figure A shows the thin paper sector OXYZ. OXYZ this sector where OX is 20, reflex angle XOZ 216. Okay, so all information can shown in the figure. By joining OX OZ together, okay, OXYZ is floated to form a right circular cone like this, as shown in figure B. Okay, so this one, that means OXOZ stick together to form this right circular cone. Part A. Find the curved surface area of the circular cone in terms of pi. This one, the curved surface area. Part B. Find the volume of the cone. Okay, this one in terms of pi. So for part A and part B, you'll see that, okay, if you want to find the curved surface area by volume, you know that is pi r L, right? Right. This one is the curved surface area, right? How about the volume? How about the volume? Yeah, you know that this one is 1/3 of pi r square h, correct? Okay, pi r square h and pi r L will be the formula for part A and part B. Then, you see, do you know radius r? Do you know length L? That means the length height. Seems not, right? How about the volume R and H? Do you know radius? No. Do you know the height of the circular cone? We don't know. Not yet, no, right? So, okay, curved surface area. Where it comes from? This one, right? That means if you know about the area of the sector OXYZ, then you know the area of the curved surface of the cone, right? Do you know area of sector? Okay, what is the formula? Area of a sector. Good. Pi r square is a area of circle, and this one is a part of a circle, theta over 360. And you know now 216 is the theta. Radius r 20. So let's see. Pi r square, okay, times 216 over 360 degrees. Okay, so as a result, 240 pi cm square is the curved surface area. Right. That's great. Very good. Then how about the volume? How about the volume? Just now I asked you one question. Do you remember? Curved surface area, this is pi r L. Do you know their lengths? R seems not. L seems not. No. You know the length of L. Have a look. This one, join OX and OZ together to form this. So actually this one is O. Okay, O. And this one is X. OX is the length height of the circular cone. See? So you know this one actually is 20. Okay, 20. So you know the length L here. How about R and H? How about R and H? Depends on, okay? You can use two method to find R. Okay? You can use this one, okay? For example, XYZ, this arc length. Maybe say that is XYZ, this arc length. Actually same as length of the circular cone. Do you know which part? Do you know which part? Yes, it's the circle. Correct, it's the circle. So we can let R be the radius of a cone, okay, by the relation between this circle and the arc length x, y, z. We can set up the equation from this. So C, 2 pi r equals 2 pi 20. That means the theta here. Arc length is 2 pi r times angle theta over 360. And now 2 pi times radius 20, okay, and you can find the arc length x, y, z. So r is 12 cm. Let me see, it's 12 cm. Okay, if you know about the radius r, then we can find by this right angular triangle. Do you know? Yeah, this one, OXA or OAX. This one is the right angle. So you know L is 20, right? This one is 20. R just now you know this 12, so you can find H. So what is H? So in the triangle OAX, H square plus R square equals L square. So H is 16. H is 16. So as a result, about the volume of the cone, you know H, you know R, so 1/3 of pi r square H, so pi 12 square 16, so 768 pi cm cube. Okay. So let's have a look. Besides this one can find the radius r, we also can use pi r l. That means the curved surface area, 240 pi equals 240 pi. And you know that just now we said that L actually is OX. So pi r 20 equals 240 pi. And you see that R is 12 cm. Okay, both can help you to find out the radius R. Okay, so let's understand clearly about these two figures, about the sector and then form as a right circular cylinder. Okay, it's a good question. Okay, hope you understand. Let's go on to have a look the other one. Question number 9. Okay, now here, a right circular cylindrical container of a base radius is 12 and height is 6 cm, and an inverted right circular conical vessel of a base radius is 22 and height 33 are held vertically. Okay, the container is fully filled with water. Container, that means the circular cylindrical container. Okay, this one fully filled with water, and water in the container is now poured into the vessel. Okay, A, find the volume of the water in the vessel in terms of pi. Part B, find the depth of the water in the vessel. And part C, if a solid metal sphere of a radius 15 cm is then put into this vessel and the sphere is totally immersed in the water, will the water overflow? Explain your answer. Okay, that means now 1, 2, and in the part C have a metal sphere also. So you can draw it. Draw what? Okay, one circular cylindrical container. Okay, second and the third one about the circular cone. Okay, maybe this one right here better. This one I want to large a little bit. Okay, like this. Okay, this one fully filled with water and then is poured into the vessel. Okay, then do you know the volume of the water in the vessel? Yeah, you know that these two are the same. The water, okay, the volume of water. So you want to find this one? Actually, it's find this volume, right? So do you remember the volume of cylinder? Okay, this one are the same actually. Okay, pi r square h, correct. Okay, pi r square h, and you know that this one r is 12, h is 6, so pi r square h, that means this, right? So as a result, pi 12 square h, 864 pi cm cube. Again, remember unit cm cube. So now this one is 864 pi. Okay, and then pour into the vessel. Okay, then find the depth of the water. Do you know the depth of the water? And you know that this one, okay, about the right circular cone radius is 22. Okay, and this one, the height of a circular cone, okay, here 33 cm, right? Then the depth of the water, that means here. Okay, what is the height of the water? That means you also need to know about this radius, right? If you can write down the relation between R and H and related to this two, actually we can use 22, this vessel radius, and the height of the vessel 33. We can know about the relation between R and H, right? Because here we have two similar triangles, right? Right. So as a result, that means you can make use of this. Okay? Okay. So what are they in ratio? You can write like this. R over 22, okay? R over 22 equals to H over 33, right? So you can write R in terms of H. That's great. It's a good way to help us write down only one, that means the depth of water, as the unknown. Only H as the unknown. Because we know that this one is 864 pi, we can use the volume of cone and then to find H, right? So what is the depth of water? Let's see. So now 1/3 of pi r square h, okay, 864, right? And you know that r is 2/3 over 2/3 h, so 2/3 h and then all square times h. So as a result, 4 over 27 h cubed equals this. Okay. Okay. So as a result, h is 18. So the depth of the water is 18 cm. Clear? Okay, good. Last question, C. If a solid metal sphere of a radius 15 cm is then put into vessel, okay, that means now we have this one and then put it into the vessel and totally out, immersed in the water. That means like this, okay? Will the water overflow? Will the water overflow? That means if you put here the sphere, is it larger than this space? If sphere volume larger than this space, then overflow, right? If not, then will not overflow. That means you need to check. Okay. Then do you know the biggest, that means the capacity of this vessel? Okay. Capacity. Do you know this word? Okay. That means the volume of this vessel. Okay. Not the water only. Okay. It's the total capacity. If you know this one, minus the volume of water, then you can find the volume of this space, right? Check it, and also in the same time check the volume of sphere. Which one greater? Then you will know the water overflow or not. So let's see. Part C. Let's have a look about the volume of this vessel, right? So the volume of vessel, I will give you first. 1/3 of pi r squared h. Okay, r now is 22, h is 33, so pi r squared h. So 5,324 pi cm cube. Okay, then how about the volume of sphere? Yeah, 4/3 pi r cube, correct. So volume of sphere, that means like this. 4/3 pi r cube. Okay, 4,500 pi cm cube. Then here is 864 pi. If you add up this sphere volume, okay, what is the total volume? Let's see. These two add up, okay, 4,500 plus 864. This one greater than total volume of the vessel. See? Then what is the answer? Don't miss the answer. Then you need to write down the water will overflow. Okay, because the question is asking you, will the water overflow? You need to answer yes or no, will or will not. Okay, and you know add up two volumes will greater than this one. That means the water overflow. Understand? You understand? Okay, that's great. Let's have a look one more. Question number 10. Just now that question, let's you have a look. This question actually related to 2018 question 14. You can check it by yourself and you can try this question, DSE question by yourself. Okay, let's see another question. This one related to 2013 question 13. Okay, let's see. Now here in the workshop, 36 identical solid metal right circular cylinder of the base radius R are melted and recast into two larger identical solid metal right circular cylinder of a base radius RCM. Okay, and the height is 32. It's given that the base area of the large cylinder is 9 times the smaller one. Okay, two cylinder. Smaller one, 36. Okay, larger one, 2 only. Okay, all this we cast into two bigger cylinder with, okay, this one is smaller radius, large radius, A1 and A2. Okay, and you know that the base radius, that means two circles will have this relation. Larger one is 9 times the smaller one. That means A2 is 9 times A1. Okay, A, find R to R, small r to big R. A2, the height of a smaller cylinder, that means here, H. Part B, a craftsman claims that larger cylinder and a smaller circular cylinder are similar. Do you agree? See? Ask you, are they similar? Okay, these two cylinders, are they similar? Explain your answer. Yeah, study the question once again. You found that no similar this term from the question. Okay, you cannot find similar solid, similar cylinder. So be careful when you find R to R. Okay, let's see. Base radius, base area of a large one, okay, to the smaller one. So this is the question given relations, okay, about the large base area and small base area. 9 times, so you see that this is the first relation. Pi r squared equals 9 times pi r squared. And see, this is the big R and this one is small r. Don't mix it. We need to find R to R. That means R over R equals to what? That means we can rearrange it, and at the end you can find out, this one 1/9, right? Okay, 1 over 9 pi r square over pi r square. Okay, small r in numerator, big R in denominator, because I want to find this one. So after simplify, get it. And R over R takes square roots, so 1 over 3. That means R to R, smaller R to big R equals 1 to 3. Great. We find the ratio between two radius now. Then, how about the height of a smaller circular cylinder? Because they are not similar, not yet, we don't know, okay? So, what can we do? What can we do? Yes, their volume must be the same, because this 36 small identical solid melted and recast into two big circular cylinder. So by using this equal volume, okay, then let's see, 36 of the small cylinder pi r square h equals to two big circular cylinder pi r square h. Okay, here we know the height of a big cylinder 32. We need to find small one. Okay, how about big R and small r? We know the relationship between two radius about the ratio. So simply using R over R equal 1 over 3. Okay, so as a result, rearrange it and you can get as 1. Small h equals to, okay, all things put it here, 2 times pi, and then this one is 3 times of small r, so 3r all square 32. After simplify, you found that height of the smaller cylinder is 16 cm. Remember units, cm. That's great. We know about the height of the small cylinder now. This one is 16 cm. Okay, so see, 16 and 32 radius we don't know. Oh no, we know the ratio. 16, 32, 1, 2, 3. Can you solve the problem in B? Craftsman claims this one correct or not? Do you agree? Yeah, if they are similar, then length of the the ratio of the heights should be equals to the ratio of radius, right? So check it. What is the ratio of the height? And you see that one is 16, one is 32, right? So smaller over the large one is 1 to 2, 1 to 2. However, what is the ratio of the radius? 1 to 3. So it's not equals to the ratio of the radius, two radius. Okay, so the answer, they are not similar. They are not similar. Clear? So be careful when you do this question, and you need to using the correct relations. For example, given that base area, okay, then we use the base area. Two volumes are the same. 36 of the small cylinder equals to two big volume, two bigger cylinders. Okay, so their volumes are the same. Okay, hope you understand clearly. Okay, remember this one is 2013 question 13. You can try this one by yourself. Okay, let's have a look at the last one today. Okay, so 2017 question 12. Okay, seems like this one. Let's have a look. Solid metal right circular cylinder. Okay, I write here. Base radius 160 cm square and the height 133 cm. Now it's melted and recast into two similar solid. Okay, that's great. See? Similar solid. That means you can use their ratio. Okay. Right pyramid. Okay. And base of two pyramids are the square. Oh, these two are the square. That means like this. Okay. The ratio of the base radius, not radius, base area, small to large is 4 to 25. So A1 to A2, 4 to 25. Okay, okay. So you may say that, oh, this one is 4K and this one is 25K because you know the ratio, right? Okay, now find the volume of smaller pyramid. Find the volume. Oh, how to find it? That means we need to use all the volume of 2 because this one we class it into 2 pyramid. So do you know the ratio of this 2 pyramid? I mean the volume ratio of 2 pyramid. Let's find it from the area. Okay. So you know that, okay, A1 to A2 is 4 to 25, right? That means if here is L1, here is L2, what is L1, L2? Actually, this one equals to 4 to 5, right? So 4 over 25. So L1 to L2 equals to 2 to 5. See? 2 to 5. If we know this one, then do you remember V1 and V2? Yes, this one equals to 2 over 5 and then take cube, correct? So 8 over 27, okay? So that means you can think it, this one, I use ratio of the volume 8 and 27, okay? Break it as 8 plus 27 parts, and then smaller one, only 8, okay? So let's see. Let's do it now. First, about the volume of the pyramid. Take the square roots, okay, to find the length first, okay, 2 over 5. Then, V1 and V2, you know that, take cube. So, you know that this one is 8 over 125. Oh, I'm sorry, this one is 125. Yeah, just write correctly. Lastly, how about the total volume of the cylinder? Yeah, we need to find the total volume of the cylinder first. So this one, base area 160 times 133. So you know that this one is 21280. Okay, this one is volume of 2 pyramid. And lastly, volume of the small one equals to this, 21,280 times of the 8 over 125. Okay, 8 over 125. Okay, plus 8. Okay, because this one only take 8 and all 125 plus 8. So as a result, this one 1,280. Clear? That's great. Goes on to have a look, part B. If the size of a base area, of the base of a small pyramid is 16, okay, length of the size is 16 of the smaller one, okay, that means this one, okay. Find the total surface area of smaller pyramid, okay. How many faces you need to find? Yeah, whatever big one or smaller one, they have one base and 4 faces, 4 lateral faces, okay. And remember, each lateral faces is a isosceles triangle, okay. You need to find the area of an isosceles triangle, okay. So let's see, maybe this one, okay. 16 is the length of a smaller pyramid, then it's like this, okay. So 16, and you need to find AB. Please pay attention about this, okay. How to find AB? Because AB is the height of one isosceles triangle, okay. And we can make use of this one. That means use this triangle. Okay, maybe I'll regulate this. Okay, AOB. If we know about this length OB and AO, then we can find AB, right? Then we can find the area of an isosceles triangle. Do you know H? Do you know H? Do you know OB? Do you know OB? OB actually is half of the size because it's a square, right? So that means here is 8. You know this one is 8. Okay? H. How to find it? How to find it? Yeah, just now we know about a small pyramid. Okay, about the volume of a small pyramid. That means we can use this one to find the H, the height of a small pyramid. So let's see. And this one is A, okay, that means the size, okay. So A square, because it's a square, times H, and then times 1/3, 1/3 of the base area times H equals 1280. So you see that, oh, H is 15, that's great. If we know this one is 18 and H, we can find AB, right? So not difficult now, because OB is half of the length, that means 8. AB will be 8 square plus 15 square, and then you will find that, oh, AB is 17. If AB is 17, then we know about the area of one isosceles triangles. 18, oh, this one is not 18, this one is 16. 16 times 17 over 2. Okay, and now we have 4 isosceles triangles and then 1 base area. So as a result, the total surface area will be the base area, 16 square, plus 4 triangles. 4 times 1/3 of 16 times 17. Okay, so total surface area will be 800 cm square. Okay, see, when you find the total surface area of a pyramid, be careful, we need to find the height of the lateral faces of this triangle. Okay, so one by one you can find the length easily, and finally remember how many faces you need to find about the surface area, then you can solve it easily. See, hope you learned something in this video. Okay.